Hello everybody and welcome to a very special video where I'm going to be recreating the classic Unity rollerball tutorial using the new entity component system, which is a part of the data-oriented technology stack. So the entity component system is essentially a new way of programming games in Unity where we separate out entities, components, and systems. And we do this so we can get really high performance out of our games. And I wanted to recreate the classic Unity rollerball tutorial so I could introduce the entity component system to you all in a nice, easy way that's going to show you how to do many of the basic features in the entity component system. Also, because we're using dots, we can do some pretty cool things like this. So in today's video, I'm going to be going over entities, components, and systems and talking about how they all interact with each other. Then I'm going to be showing you how we can use traditional game objects and convert them to entities. I'm also going to show you how to spawn entities through code. And then some of the systems that we're going to be creating are showing you how to roll the ball around the stage, as well as making the cubes rotate. Also, I'll be showing you how we can use the cubes as triggers, so when we roll the ball into the cubes, we can pick them up and increment our score. I'm going to be showing you how we can destroy entities through code. And then I'm going to be showing you how we can use our GameObject camera to actually follow the entity of the ball. And be sure to reference any of the time codes down in the description if you just want to jump to a certain section in the video. Also down in the description you'll find links where you can download the completed project as well as the assets used to create this video. And real quick, I'd just like to say if you do find this video helpful, make sure you leave it a like. Also feel free to subscribe to the channel for lots more videos on the entity component system and the data-oriented technology stack. Of course, if you have any questions for me or suggestions for future videos, feel free to leave those down in the comment section below. So real quickly, I'm just going to go over the entity component system. So basically, we just have entities, components, and systems. So entities are just kind of representations of things in our game world. So in this example, this would be things like the ball, the cubes, and actually the stage geometry. Next, we have components, which actually hold the data associated with these entities. So in this case, we're going to be using some data components which control how fast the ball moves, as well as how fast the cubes rotate. And then finally, we have systems, and systems hold the logic that affects the entities in our scene. So in this example, we're going to be creating systems to actually move the ball around the stage, as well as rotate the cubes and perform the trigger behavior when we actually run into the cube so we can pick it up and increment our score. Now, real quickly, I should mention that in this video, we're not going to be using 100% ECS for everything, because at the time of recording, ECS is still in a preview phase and not everything has been, moved over to the new entity component system. So we're going to have to do some things still in mono behaviors. But I think that is an alright thing because, when you go to make your game in ECS, you probably will end up having to create some things with mono behaviors. So I'm going to be showing you how we can interact between entities and mono behaviors. But anyways, I think that's enough talk. Let's go ahead and get into the tutorial video. So of course, we're just going to start with a blank project here. I'm using Unity version 2019.3.0. And at the time of recording this is actually a preview version of Unity. But anyways, we're going to be importing the 3D templates here. Just go ahead and give it a project name of dots rollerball and save that to wherever you like. All right, so once we have Unity loaded up, we can go ahead and import a couple preview packages. So we'll just go up to Window and Package Manager. And we'll go ahead and open the Package Manager here. Now, the first thing you need to do is go to the Advanced tab here and make sure Show Preview Packages is checked marked, so it'll look just like that. And then also make sure you're looking under the All Packages here. So we have to import 3 different preview packages. The first one is going to be entities. So just go ahead and click on that and click on install and go ahead and let that install. And this is the package that's going to give us access to the actual entity component system itself. All right, and once that's complete, the next package that we're going to need to import is the hybrid renderer. So just go ahead and click on the hybrid render. Again, click install and wait for that to install. And this is going to allow us to actually render the entities within our scene. All right, and then the last one that we're going to need access to is Unity Physics. So we'll just go ahead and install that last one. And of course, this is going to allow us to use the new physics system, which integrates with the entity component system. All right, so once we have those 3 packages installed, we can just go ahead and close out of the package manager. And there's one more thing we need to set up in our editor. We just want to go up to Window here, and then under the Analysis section, we're going to open what's known as the Entity Debugger, and then you'll see a little window pops up here. I just like to put this right next to my console here so I can flip back and forth. But this is going to be the main kind of debugging window that we're going to use when we start making entities and everything, so we can actually see the entities themselves, along with what components are associated with them, and even the systems that are impacting those entities. So this is a really helpful window to have, so make sure we have that open. All right, so we're just gonna go ahead and create some basic scene geometry, pretty standard Unity stuff. We're just gonna start with a 3D plane here. We're gonna make this a 2x2 size, and then we're gonna just put some walls on it, and these are gonna be the dimensions that you're gonna be putting on all the walls. All right, and then once we have that set up, I'm just gonna go ahead and import some materials that I had here. Just go into the materials, I have this ground material, just a nice simple blue material here, just to kind of give it a little bit of color. And then real quick, just gonna change the angle on the camera here. All right, so this is looking pretty good. So before we go any further, I think we should just go ahead and save the scene real quick. I'm just gonna call this the roller scene. All right, so next we're gonna add some things to these basic geometry objects in our scene. So we'll just go ahead and highlight everything, just the plane and the 4 walls here. We're gonna go ahead and go to add component, and then we're just gonna go ahead and add a rigid body component. And when we actually convert these game objects to entities, the colliders are going to be converted into what are known as physics shapes, and the rigid bodies are going to be converted into what are known as physics bodies. And so actually, if we want, we can actually add in a physics body or a physics shape if we want to, but I just want to show that you can actually convert these rigid bodies and mesh colliders dynamically. Real quickly, one thing we need to do on the rigid bodies, so just go ahead and highlight all of them again. We're gonna uncheck use gravity, and then we're gonna check is kinematic, because these are just kind of static objects in our scene that we don't want to be moving anywhere. So now it's pretty easy how we actually convert these to game objects. So we're just gonna go ahead and add a component, which is going to be the convert to entity component. So we'll click on that, and the conversion mode is set to convert and destroy. So what exactly does that mean? Well, I'm gonna go ahead and show you now. So you'll see, of course, that we have these 5 objects showing up in our hierarchy here. However, when we go into the play mode, things are going to change a little bit. So you'll notice that all those objects that we had, they disappeared from our scene hierarchy, and they're actually nowhere to be found in there. However, they still are showing up in our scene, so they're not completely disappeared. So where did they go? Well, that's where we start getting into the entity debugger here. So you'll see when we go into the entity, we have all the entities listed here. So we have the 4 walls and the plane, and we can actually click on these here, and we can see all the associated values showing up in the inspector, just how we would with a normal game object. And even further than it just listing all the components, we can click on this where it says used by systems, and it lists out all the systems that are associated with these different entities. All right, so because this is the roll a ball tutorial, the next thing that we're gonna add in is a ball for us to roll. So again, we'll just go up here and we'll just create a 3D object that is a sphere. And we'll just set the Y position to 0.5 so it sits right on top of that plane nicely there. And so what we're gonna do this time is we're actually gonna go ahead and remove the sphere collider, and we're gonna go ahead and add a physics shape, which we can set to shape type of sphere, and just go ahead and leave all the default values. We're gonna add another component, which is gonna be a physics body. And so because we're going to be moving this around, this is going to be a dynamic body, and we can just go ahead and leave the rest of the defaults as is. And lastly, because we're going to be converting this to an entity, we're going to go ahead and add the convert to entity component here. Make sure the conversion mode is set to convert and destroy. And then I just have a ball material here, which we're going to go ahead and apply to it. Just this nice little basketball here. So just a nice little thing that we can actually see when this ball is rotating. So anyways, real quick, I'm actually just gonna raise this sphere off the ground temporarily so that you'll see when we go ahead and hit the play button here, you'll see that it automatically starts to interact with the Unity's physics engine. And then boom, there you go. Gravity is working as expected. And so of course, if we wanted, we could give this like a bounce material, make it bounce off the floor, but we're not gonna do that for now. So I'll just go ahead and put this back on the floor at a height of 0.5. All right, so now we pretty much have our basic entities. So now it's time to start adding some components to them. And we're just gonna be starting with one component. This is going to be a speed component. which we're going to be adding to the ball here so we can kind of regulate how quickly the ball moves around. All right, so just in the assets folder here, I'm going to go ahead and create a new folder called scripts. And then under the scripts folder, I'm actually going to create a couple new subfolders. One is going to be for our data components. And then we're gonna have another folder for our systems. And this just kind of separates things out, makes things a little bit more organized. So anyways, we're gonna start with a data component here. So we're gonna go ahead and create a new C# script. And I'm just gonna go ahead and call this SpeedData. And then, so we'll just go ahead and double click that to open up in our IDE of choice. All right, here we go. Time for the fun stuff. Here's some coding. So we're just gonna go ahead and clear out everything in here because we don't need any of that. So first we're just gonna start off by including a library. So we're going to be using unity.entities. And so this is going to be a public struct, and it's gonna be of type SpeedData, of course. And so this is actually going to inherit from an interface known as iComponentData. All right, so we're just gonna go ahead and open and close the curly braces here. And then we just need one public variable, which is going to be a float, which is going to be our speed variable here. And if we wanted, we could add in, more fields here. Like if we wanted some type of counter, we could have that in here. However, for this particular data component, we just need this one speed variable. And then the only other thing that we need to do in this script here is we're going to add a tag. So this is actually going to be the generate authoring component tag. And what that is going to allow us to do when we save this and go back to Unity, once that all compiles, we can just go ahead and drag the speed data component and go ahead and put it on our sphere here. And we can see that we can actually edit this value. So we can put, whatever we want for the speed. So if we wanted a speed of 10, we could put that in there. If we wanted a speed of 3,000, we could put that in there. But I think 10 is probably something good to start with. And so that's the basics of a data component. It's very simple and straightforward. So now things start to get a little bit more fun when we add in some systems. So we're gonna go ahead and add our first system, which is going to be the movement system, which is gonna allow us to actually move the player ball here. So in the system subfolder, we're just gonna go ahead and create a new C# script, and we'll just call this our movement system. And once we have that, just double click to open. All right, so here we can just clear out the start and update functions, and we'll just clear out all the includes that we have here. And these are the libraries that we're gonna be importing. So it's unity.entities, unity.jobs, unity.physics, unity.mathematics, and the Unity engine. The next thing that we need to do here is instead of inheriting from mono behavior, we're actually gonna be inheriting from the job component system. You'll see that when we do that, we're already getting a little bit of an error here. So we can just click on this, and in Visual Studio, it's really nice. You can do Alt-Enter and then hit Enter one more time. Then it goes ahead and puts in this one needed function, which we need when we inherit from this job component system here. And so this onUpdate function, it's similar to the regular update function. It's called every single frame, and this is going to be where actually most of the work in the entity component system is done, is within these onUpdate functions. So actually the first thing that we're going to do is we're going to get a float variable, which we're going to be calling delta time, and then we'll set this equal to time.delta time. And the reason we do this is because we're going to be doing a lambda function in just a second here, and we actually can't grab delta time from inside that lambda function, so we just need to do it outside like this. So no big deal. Next, we're going to do a float2 variable. And a float2 is basically, it's similar to a vector2, it just holds two floats, but it's a little bit more lightweight. And that is included with this unity.mathematics library here. And so we're just gonna go ahead and call this the cur input. And we're gonna set this equal to a new float2, taking in input from the vertical and horizontal axes. All right, so once we have those two things, we're gonna be implementing our lambda function. Again, start getting used to these because we're gonna be using them a whole bunch in ECS. So the way we actually do this is we say entities.forEach. So do open parentheses, another open parentheses. First, we're going to be getting a reference to physics velocity, and we can just call that VEL, vel. Then we're gonna say in speed data, and then we'll just call this Yeah, SpeedData, that's fine. So what this means is it's going to iterate through all the entities that match these parameters here. So we do entities.forEach, and we pass in a reference to physics velocity, and then in for SpeedData. So this basically is going to iterate through every entity that has a physics velocity as well as a SpeedData component associated with them. Now the ref is a reference, meaning that we can read from as well as write to the physics velocity. And because we're going to be, actually moving the player, we need to read what it is currently. We're going to make some modifications to it and then write to it so we can actually update its velocity, which is going to actually move the ball. And then the in keyword, this is basically when we just need to read data from something. So we're just going to be reading the speed data just to know how fast to actually move the player. This isn't something that we need to modify, so we just use the in keyword here. All right, so next, after the first end parentheses, but before the second, we're just going to go ahead and do an equal sign and then make an arrow like that. And then we're going to do an open close curly braces. At the end, we're going to do a semicolon. And then we can actually put these braces kind of on their own lines here and separate this out. So here's what we're actually going to be doing within this for each loop here. So first, we're going to get another float2 variable for new velocity. We're going to set that equal to vel dot linear, so this is its current linear velocity, dot xz. So this is its current linear velocity in the x and z directions. We only care about x and z because, again, this is just kind of moving on the 2D plane there. So after that, we're just going to go ahead and say new velocity plus equals cur input, so whichever direction the player is inputting. So if we're inputting a forward or a left or some kind of a diagonal direction, we're going to get that here. We're going to multiply that by our speed data dot speed. So that's just the speed value that's attached to that speed data component. And then of course, we're just going to go ahead and multiply that by the delta time that we captured. And then the last thing that we need to do is just apply this new velocity back to the current velocity. So we'll just do vel dot linear dot xz, set that equal to the new velocity, just like that. And so now that we have the code here, we just need to tell the job system to do a dot run. So we'll make sure this is, after that last parentheses, but before that semicolon that we put there. And the dot run just means that we're going to be running this operation on the main thread. And then after that, you'll see that the onUpdate function is still giving us an error. All we need to do is just say return default. And that's pretty much all set. One thing that we do need to do is just right above here, we're gonna add in a tag, which is the always synchronized system tag. And basically when we're running things on the main thread in ECS, we just wanna include that tag just so it syncs everything properly. Now we can head back to Unity and let everything compile, and then we can actually go ahead and test out our game. All right, so now that it's compiled, we'll just go ahead and enter play mode here. And then you'll see we can use the WASD keys and we can start rolling the ball around. So boom, there we go. We're already rolling the ball around for the Unity roll a ball. Now you can already tell that things are quite different than traditional Unity programming. And we're gonna get into some weird stuff here, but hang on, I promise it's not all that intimidating and we can start to do some really, really cool things. And then real quickly, while I'm kind of messing around in play mode, I do want to point out one quick thing in the entity debugger here. So you can see all the active systems listed here. And you'll see that one of our systems is the MovementSystem. So we can actually uncheck that. And if we go back over into here, I'm pressing the WASD keys, but nothing is happening. And that's because the system has actually been disabled. However, we can just re-enable that, come back over here and just start moving again. So again, this can be pretty handy to start debugging things. You can, uncheck different systems that are running here to test out different parts of your code. Okay, so now that we have the ball rolling around, the next thing that we can do is start adding some cubes for the ball to pick up. So again, we're just going to go ahead and go up here and we're going to go ahead and create a 3D cube. And then I just have a basic little yellow material to apply to this. And then so again, we'll just actually go ahead and remove the box collider and we'll add in our physics body, physics shape, and convert to entity components. Now we're gonna set these boxes as kinematic because we don't need them to, you know, mess with gravity or anything like that. So we'll just go ahead and call this the pickup cube. And so I'm gonna go ahead and make this cube a prefab. So I'll do a little prefab folder here, pickup cube in there, and then we can go ahead and just duplicate out a couple of these here. Okay, one thing that I forgot to do that we can just do on this main one here is we need to make this a trigger. So on the physics shape, there's an option for is trigger. You just go ahead and check mark that, and I'm gonna go ahead and apply this to the prefab, and then these all should be showing up as triggers. And so this is gonna allow us to, when the ball runs into it, we can just activate a trigger and we can actually pick it up instead of, you know, colliding with it and maybe knocking it off into space or something, which would be cool, but that's not what we're going for today. So next thing that we want to do is we're actually going to be rotating these. So of course we're going to need some sort of rotator system. And of course it's going to have some kind of speed of how quickly we want this to rotate. And if you remember, we actually already have a data component for our SpeedData. So if we want, we can actually just go ahead and apply this SpeedData right onto you know, one of our cubes here. Make sure this, of course, applies to all of them. And we can just go ahead and give this a speed of, say, 5. We can have them go ahead and rotate at 5. And then we'll just go ahead and apply that speed to all of them there. Now, however, what I just did there is incorrect. And I'm going to show you why right now. So if we go into play mode here, obviously we haven't created our rotating system, so they're not going to start rotating. So what's going to happen is when I use the WASD keys to roll around, you'll see that, whoa, all the cubes start running around with the ball, which again, kind of funny, but not what we're going for in today's game. So now the reason that happens is in our movement system here, this is iterating this movement system on everything with a physics velocity component and a speed data component. So not only does the ball have a physics velocity and speed data component, but all these cubes do as well. So luckily there's a pretty easy fix for that. We can just go ahead and create a new data component here. So we'll just do a new C# script. We'll just call this the rotation speed data. And so we actually just go to our speed data component, just go ahead and copy this and delete all that and paste it over. Make sure we just change the speed data to rotation speed data. And again, we can just have this public float called speed. So we can save that, head over to Unity and let that compile. And we can actually just open up the cube prefab here. We're gonna go ahead and remove the speed data component, add on the rotation speed component, and then put on a rotation speed of 5. So now you'll see that we can go ahead and roll around here, and you'll see that the cubes all stay just in place, and we can continue moving the ball around just as we would. So now let's go ahead and actually implement this rotation system so we can get the cubes to rotate all cool like. So we'll just go into systems here, and we're gonna go ahead and create a new C# script, which is going to be our rotation system, and open that up. Of course, we can blow away the update and start functions, as well as these includes up here. And so we're gonna be using these includes instead. So it's unity.entities, unity.jobs, unity.transforms, and unity.mathematics. And of course, again, we're going to be inheriting from the job component system. And so once again, we're getting an error. So we can just click on this, do Alt Enter and enter. And so the rotation system is fairly straightforward. Again, we're just going to want to do a float for delta time. So we get a reference to the time.delta time here. We'll do the lambda function again. So entities.for each. This time we want a reference to anything with a rotation component. We'll just call this rotation. And we're just gonna read from anything with the rotation speed data. And so we can just call this rotation speed. Anyways, of course, we're gonna need to do this interesting little arrow thing in the brackets. Put Put the little semicolon at the end, make these lambda expressions all nice and neat. And then, so basically what we're gonna do is just rotate it across the X, Y, and Z axis at the same speed, just every single frame. So pretty simple. The way we do that is we just do our rotation.value. So that's how we get the current rotation value. And this is a quaternion, so we need to kind of do some interesting little maths on here. So we'll do math.mul, passing in the current rotation.value, and we're going to be multiplying that with quaternion dot rotate x to rotate this in the x direction. Here we're going to be passing in math.radians of our rotation speed.speed multiplied by delta time. So again, this may be a bunch of weird mathematical things, but pretty much we're just going to be rotating this around the x-axis at the specified speed every single frame. And so we can just copy this line here and paste it again, and we're just gonna change this to rotate Y and rotate Z. Of course, we're gonna be running this on the main thread, so we'll just do a dot run at the end here. And then once again, return default. And lastly, we're just gonna go ahead and give this the always synchronized system tag here. Go ahead and save that. Back over to Unity, wait for it to compile. All right, and once it compiles, we can just get a nice view here. And then if all goes well, when we hit play, all our cubes should start rotating around all three axes. Boom, there we go. We see they're rotating a little bit slow. So again, we can kind of stop this, go to one of these cubes. We can increase the speed to, 25. Let's make it go pretty quick. And apply the changes. All right, there we go. And we have all our cubes rotating. So they're kind of like intriguing for you as the player to, want to actually go and pick these things up. So of course we can move around, and we're just going to be going right through them because they are set up as triggers. So we're not colliding with them or anything like that. So the next thing that we need to do is put some kind of logic behind them to say, what happens when we actually enter one of these triggers here? How are we going to pick them up? So the way we actually do this is a little bit interesting in ECS. So the way that I'm going to be showing you how to do this today is when we collide with one of these, it triggers a trigger event. And when that trigger event happens, we're going to apply a delete tag to the cube. And then so at the, near the end of the frame, we're actually going to run this operation that scans through all entities with a delete tag. And if it has that delete tag, it's actually going to delete the entity. So it's kind of like an extra step you have to take instead of just saying, when I collide it, I delete it, but that's just kind of how working with ECS is right now. So first we're going to add another data component, and this is just going to be a very, very simple one. And this is just going to be called the delete tag. It's not even delete tag data or anything like that. It's just delete tag. And you'll see why, because we're pretty much putting nothing in here at all. So just go ahead and clear all that out. We can just go to another one of our data components here, copy that all over and paste it in. Again, this is going to be the delete tag, and we actually don't even need any variables at all. So this is literally what our delete tag looks like. Basically, it's just an empty component that, again, nearing the end of the frame, when we actually scan through everything with the delete tag, anything that has this is gonna get deleted. So this is pretty much all we need, just completely empty. Super simple. So before I show you how to do the pickup system, because that one's gonna be the most complicated, I'm gonna show you how to make the delete system, because this one is pretty straightforward. So we'll just do a new C# script, call this the delete entity system. Of course, just clear all that out at the beginning and all that out there. And this time we're just gonna be using unity.jobs, unity.entities, and then unity.collections. Once again, we're just going to be inheriting from the job component system, and go ahead and implement this on update function here. And so the first thing that we're gonna be using here is something known as the entity command buffer. And we can just call this command buffer. And we'll set this equal to a new entity command buffer, and then passing in allocator.tempJob. So basically this entity command buffer we can use this for a couple of different things, and we're going to be using this in the pickup system. And so pretty much we can kind of use this to queue up different jobs within a job, and then at the end we can actually play through all those jobs. And this entity command buffer, it's going to allow us to do some pretty cool things, such as adding components to GameObjects, which we're going to be doing, of course, in the pickup script. And in this case, we're actually going to be using it to delete entities entirely. So this time around, I'm going to show you a little bit of a different way to do Lambda functions, but it works just the same. So we're going to do entities, and we're going to go to a new line. And then if you're tabbed over just like that, so we're going to do a dot with all, passing in the type of DeleteTag. So this pretty much means it's going to run on all the entities with the delete tag. And then just do open and close parentheses there. And then we're going to do another line, and then we're going to do a dot for each. This is where we do our for each inside here. We're going to do an entity. We'll just call this entity. And then here's kind of where we do this like we were doing before. So then here, all we're going to do is go to command buffer and do a dot destroy entity. And then we're just going to go ahead and pass in the entity, which we called entity. And so that basically kind of gets this in the command buffer, saying that when the command buffer runs, this thing that we're going to do is destroying an entity. So if we had like a bunch of things with this delete tag, then of course we'd iterate through all of these, and then we'd add this destroy entity, passing in that entity to the command buffer. Once we have all those queued up, then we can actually play through all those things in the command buffer, which will actually go ahead and delete the entities. So real quickly, we'll just do a dot run here, because we're going to run this on the main thread. So then after this, we're going to do command buffer dot playback, and then we need to pass in an entity manager, and we can just pass in entity manager just like that. And then one thing that we need to do with this command buffer is just do a command buffer dot dispose. And then so that just kind of like, clears it out of all the memory because we don't need it anymore. And then lastly, of course, we just need to go ahead and return default. So anyways, this was a little bit of a different way of setting up these Lambda expressions. We're going to actually come back to this script, and we're actually going to add like another element here. You can see that we can just kind of do pretty much just like a new line and do a dot, with all, a dot for each. We're going to add another little element to there in just a second. But for now, we can save this, go back to Unity and make sure everything's compiling without any errors. So now we could go into play mode, but nothing's going to happen because nothing is actually getting this delete tag. Actually, I could show you real quick. We can just go ahead and put this delete tag on one of our cube prefabs here. Make sure we just apply those changes, and then just kind of verify that everything, has this delete tag. But pretty much what's going to happen is when we hit play, it's just going to delete all the cubes. So we'll hit play, and boom, all the cubes are gone, just like that. So we'll just go back to this prefab, and we no longer need that delete tag. Go ahead and apply those changes. So pretty much what's going to happen now is we're going to use this pickup script for when we run into one of these cubes. We're just going to add the delete tag to it, and it's going to go ahead and delete it. So go back into the systems folder, and we're going to create a new C# script, and this is going to be the pickup system. Again, clear out the start and update. This time around, we're going to be using unity.entities, unity.collections, unity.physics, unity.physics.systems, and unity.jobs. Once again, inheriting from the job component system. And then of course, we're going to need to add in the onUpdate function here. And so actually, I'm just going to leave this not implemented exception here because we're going to come back to this onUpdate function. So under this, we're going to go ahead and actually create a new private struct, and we're going to call this the trigger job. And this is going to inherit from iTriggerEvents job. And then so again, we can just click on this, do an Alt Enter and enter, and you'll see that we need this execute method as part of this interface for the iTriggerEvents. Pretty much what's going to happen is anytime that a trigger event happens, this execute method is going to be called. So within here, we can run some checks on the entities that actually threw this job. So then we can kind of determine which one is which, and then apply the delete tag to the cube, and then we'll actually delete the cube. And so you'll see if we go here and we do a peak definition on this trigger event, you'll see that there is an entity pair called entities. And on this entity pair called entities, and then if we go peek the definition of the entity pair, you'll see that there's an entity B and an entity A. So essentially what this means is this trigger event, we can access the two entities that are part of that trigger event. So one's going to be the object and then one's going to be the trigger. We're going to do just a regular if statement, but before we put in that logic, we actually need to set up a couple variables here. So above the execute function within this struct here, we're going to have a public component data from entity, and that's going to be of type SpeedData. Again, this is the SpeedData component that's attached to our ball. So we can call this speed entities. So this is essentially what's known as a native array of all the speed entities within our scene. Next, we're going to do a read-only tag on a public component data from entity again, and this time it's just the delete tag is what we're going to do that on, and so we can call this entities to delete. And lastly, we're going to need a public entity command buffer. We can just call this our command buffer, and again this is going to allow us to add the deletion tag to certain entities. In the execute function, we're going to say if speed entities dot has component trigger event dot entities dot entity A. So basically this is kind of a long way of saying if entity A of this trigger event has a component that is speed entities. We know this basically means entity A is a ball because only balls have the speed entities component. So if that's the case, we're going to do another if check. This time we're going to check if entities to delete dot has component trigger event dot entities dot entity B. So we're going to check if entity B already has a entities to delete component. If it is, then we don't need to add another delete tag to it. So if that's the case, we're just going to go ahead and return here. Otherwise, we're going to do a command buffer dot add component, and we're going to pass in the entity that we want to add the component to, which in this case is going to be trigger event dot entities dot entity B, and the component is going to be a new delete tag. So again, what's going to happen is when one object collides with a trigger, this trigger event is fired. So first we're going to check if entity A has a component of speed data, and so if it does, then we know that that object is a ball. And realistically after this, it might be a good idea to check if entity B also has a component of that rotation data, so we know that that other component is in fact a cube. But however, because this is a pretty simple thing and the only things that have triggers are cubes, we can pretty much guarantee that it's a cube that we're colliding with. However, we do want to check that cube, so entity B, which is the other thing, we're going to check if that has component of the delete tag. And if it does, then we don't need to add another delete tag to it. So we're just going to return out of here. But if it doesn't already have it, then we're just going to do a command buffer that add component, again, passing in that entity B and then that delete tag. So it'll add the delete tag to entity B. So one thing you may have noticed is we actually don't know if entity A is going to be a trigger or if entity B is going to be our trigger. So we actually have to check in both cases, and we flip A and B each time. And the easiest way I've found out to do this is just to create its own separate little function. So I'm just going to go ahead and implement that now real quick. All right, so pretty much what I've done here is I've separated out this test entity trigger function, which just takes in entity variables for entity 1 and entity 2. And then up here, when I make the calls, I do entity A, then entity B, then I call it again, passing in entity B, then entity A. So basically it checks both cases. So it doesn't matter if A is the trigger or B is the trigger, we're gonna find it either way. So now that's all well and good. However, we actually never, schedule this trigger job to work. So within the onUpdate function here, here's where we're actually going to go ahead and implement that. So we're going to create a new trigger job, and we'll just call this trigger job. That's fine. We'll set this equal to a new trigger job, and then within some brackets here, here's where we actually set these three variables. So we need to set the speed entities, entities to delete, and the command buffer. So for speed entities, the way we do that is we'll just type in speed entities and we'll set that equal to get component data from entity, passing in speed data. So again, this is just going to return an array with all the entities with a speed data component. So we'll do a comma at the end and then do the next variable, which is the entities to delete. So again, we're going to set that equal to a get component data from entity. This time we're going to pass in the delete tag here. And then lastly, we need to set the command buffer. However, to do that, we actually need to initialize the command buffer. The way we start that is we're going to do a private variable outside of here, which is the begin initialization entity command buffer system. So, you know, it's pretty self-explanatory exactly what that is. And we'll just call that the buffer system. I know it's a whole bunch of words, but basically this is just how we initialize the command buffer. And then here, we're actually going to need to do a protected override void for onCreate. And then in here, we can do buffer system, set that equal to world.get or create system, passing in a type of begin initialization entity command buffer system. So now we can go back into the on update, set the command buffer equal to buffer system dot create command buffer. So that's pretty much how we initialize this command buffer here. Again, we start with this private begin initialization entity command buffer system, just call that buffer system. And then we'll set that equal to world get or create system. Don't make me say it again, but you get it. And then, so the command buffer, we set that equal to buffer system dot create command buffer. So again, that's just how we create this command buffer, which is going to allow us to add components to entities pretty much. All right, so anyways, we're done initializing the trigger job. So we'll just do a semicolon at the end there. And then of course we need to return from this on update function. So we're actually going to do a return trigger job dot schedule. So we're doing a dot schedule this time instead of a dot run. This means that we're going to be scheduling this to run on one of the worker threads as opposed to the main thread. And then so if you open the parentheses, you'll see that we're going to need an iSimulation, a reference to the physics world, as well as the input dependencies. So again, outside of here, this is just going to be a private build physics world. We'll call it build physics world. Also, we're going to do a private step physics world. Call this step physics world, just like that. Now in the on create, we just need to initialize the build physics world. So we'll set that equal to world.get or create system. Again, just passing in build physics world here. And then to initialize the step physics world, same thing. We're just gonna do world.get or create system, passing in the step physics world. So now that we have our step physics world, we can pass in the step physics world dot simulation. Then again, next we need a reference to our build physics world dot physics world. And then lastly, we can just pass in the input dependencies, which we got just from the on update function here. And so that is our very wordy trigger system. So we can just go ahead and save that. Now, real quickly, we're gonna head back over to our delete system to add in a few tags there. And so after we have our pickup system created, real quickly, we can just go ahead and add the always synchronized system tag. And then one other tag that we need to add in is the update after tag. And so we're actually going to update after type of pickup system. This basically means this function here is going to update after the pickup system has been completed. Now you remember the pickup system is where we put this tag on. So of course we want to check if the delete tag is on the object after it would have already been applied to the object. Head back over to Unity, we'll let it compile, make sure we don't have any errors, fingers crossed, and looks like we are all good. So now we can test it, and if all goes well, when we hit play here, we should be able to run into these cubes. It's gonna tag that cube with the delete tag, and then it's actually gonna go ahead and delete it. So let's see how well this works. And we hit it, boom, goes away, goes away, goes away, goes away, goes away. And you can actually see over in the entity debugger where it has the pickup cubes here, when we're running into them, they're actually being deleted out of the entity debugger. So it is literally deleting these entities. So those entities are no longer there. They're a thing of the past. Okay, so now we have our basic rollerball working. Now is the time to add some kind of quality of life features, and we can kind of start adding in some mono behaviors, and we're gonna have the entity component system start talking with those mono behaviors. So the first thing that we're gonna do is add in a game manager, and this is gonna keep track of our player's score. So real quickly, I'm just gonna add in a UI text component here. All right, so now we just have this basic score counter up here, and this is what we're gonna be using to keep track of score. So we're just gonna go ahead and create an empty game object here. Just reset that transform because, you know, that's what you do. And we're gonna call this our game manager. And then just at the root of the scripts, this is where I'm gonna add in the scripts here. So I'm gonna go ahead and add in a new C# script here, which is going to be our game manager script. Double click that to open, and good old mono behaviors. Isn't this a sight for sore eyes right now after all that weird ECS programming that we've been doing? So here's the libraries that we're going to include: system.collections, Unity engine, unity.entities, unity.mathematics, unity.physics, Unity engine.ui, and unity.transforms. So I am going to make a public static game manager called instance. Just gonna go ahead and make this a singleton so we can access it to increase our score pretty easily. So if you've done some programming in Unity, a lot of this is gonna be pretty familiar. So I'm just gonna go ahead and run through what I have here. Of course, I have a public game object for a ball prefab because we're actually going to be instantiating that through code here and converting it to an entity, so that's pretty cool. We can do a public text object for the score text, so of course we can increment the score text. And then we have private variables. We have an int cur score. We have a private entity for the ball entity prefab, which is what we're going to be using when we convert the game object ball prefab to an entity prefab here. Next, we're going to need a private entity manager called manager, and we're going to use that to actually instantiate the object within our world. We're also needing this private blob asset store, which we'll just call blob asset store. Within the awake function here, we basically just set up our singleton, pretty standard. Now for the manager, we're gonna set this equal to world.default game object injection world.entity manager. Again, this is just a weird way of saying set up the entity manager. For blob asset store, setting up that is much simpler. You just set that equal to a new blob asset store. Next, we need the game object conversion settings called settings, and we'll set that equal to game object conversion settings dot from world, passing in world dot default game object injection world and the blob asset store. Now again, it's just a very verbose way of setting some things up so we can spawn entities within our game. And then lastly, we'll just set up this ball entity prefab, and we'll set that equal to game object conversion utility dot convert game object hierarchy, passing in the ball prefab as well as the settings that we just set up here. So basically this just kind of takes our game object prefab and turns it into an entity prefab. So it's not instantiated yet, it's ready to be instantiated. And then one thing that we need to make sure that we do within an onDestroy function here is we need to do a blob asset store.dispose, and that just kind of cleans up all the memory so that the next time we run our game, it doesn't have the blob asset store from the previous instance of our game. Okay, so moving on down, just have a simple start function which sets the current score, tells it to update the score display as well as to spawn the ball. Here we have a public void for increased score, and we want this to be public so we can access it from another function within our code. And all we do is we just increment the current score and then we update the score display. You can see that all we're doing for updating the score display is we're doing score text.text equal to score, passing in the cur score here. So then lastly, here's our spawn ball function, and basically what this is going to do is it's going to say entity new ball entity is equal to manager.instantiate, and we're going to pass in that ball entity prefab which we created up in that awake function. So again, this is actually what's going to be using the entity manager to instantiate the game object in our world. And then here we can actually set the translation, basically the position of the ball. And so if we want, we can set this to 5F. So this is actually going to spawn kind of up in our world and then drop down. So you'll see that. And then the last thing that we need to do is just actually add the component data of this ball trans that we created here, this translation, and then actually assign that to the new ball entity. So if we save that, we can go back to Unity here and start setting some things up on our game manager. So of course we'll add the game manager script to the game manager component. So now we can take the roller ball and we'll put that in our prefabs folder. We'll make that a prefab, and then put the roller ball on the ball prefab here. And then we can actually delete that roller ball out of our scene because we're going to be instantiating it through code, of course. And then lastly, the only other thing that we need to do is just grab our text and apply it to the score text. So now when we hit play, see that the ball spawns basically 5 units up and drops right down. Now when we roll around, see that we can collect them. However, the score is not incrementing because we actually need to call that score increment function. So we're going to be doing that right now. All right, so we're actually going to call the increment score function from our delete entity system. So right before the command buffer.destroy entities, what we're going to do is just do a GameManager.instance.increase score. And then one thing that we do need to do, remember I said that we were going to come back to this script here, is when we do this, unfortunately we can't use the burst compiler. So we have to do an enter and dot, and we just say without burst. And so this is going to turn off the burst compiler for this particular function here. And this is going to allow us to call the increase score on our game manager. So if we save that, so we'll come back to Unity and we have no errors or anything. So that's looking good. Go ahead and hit play here. And then again, the ball should spawn into our world, drop down. And now when we go collect these cubes, you'll see that the score increases. So 1, 2, 3, 4, 5, and then we can make sure that we go all the way up 10, 11, and 12. So we've collected all the cubes. Now, one thing part of the classic roll-a-ball tutorial is to actually get the camera to follow the ball. So that's the next thing that we're going to do. And this camera follow script is actually going to be another mono behavior. However, it's a little bit different than a traditional one, of course, because we're going to be looking at the ball entity and we're going to be looking at its translation component. And from that, we can kind of calculate where the camera needs to be. So it is a traditional mono behavior. However, we're doing some untraditional things of it by integrating it with the entity component system. So let's go ahead and do that right now. So again, just at the root of our scripts folder here, I'm going to go ahead and create a C# script, and this will be the camera follow script. So here, the libraries that we're using are unity.entities, unity.transforms, unity.mathematics, and Unity Engine. And like I said, this is just the camera follow class deriving from mono behavior. And again, we're going to make this a singleton, so just public static cam follow. Call this instance. We're gonna need a public reference for an entity, and this will be the ball entity. We need a public float 3 called offset. Again, this is a similar idea to a float 2, which we used earlier. This is kind of the equivalent of a vector 3, but it's a little bit more lightweight because it doesn't have a whole bunch of data associated with it. And then lastly, we're gonna need a private entity manager, which we can just call the manager. Then our wake function here, we can just do the standard singleton setup stuff here, and then we just need to initialize the manager to world.default GameObject injection world entity manager. And so of course, because we want our camera to update every frame, we're actually going to want it to update at the end of every frame. So we're going to do a late update. Within here, we're just going to do a quick check on the ball entity. If it's equal to null, just go ahead and return from here. Here we're just going to do a translation component for the ball position. We'll set that equal to manager.get component data of type translation, of course. And then here we actually pass in the ball entity itself. So this just basically gets us the 3D position in the world of the ball. So now we're gonna set the transform.position of the camera equal to ball position dot value plus offset. And so we can go ahead and save that. Then real quickly, just on our game manager, on the spawn ball, one thing that we need to do is we'll set the camera follow dot instance dot ball entity equal to this new ball entity. So the camera has a reference to the actual ball entity. And I'm gonna go ahead and put this back to 0.5 just to spawn it right on the floor. All right, then of course, we'll go to the main camera, apply the camera follow script, and I'm gonna do an offset of 8.5 in the Y and negative 11.5 in the Z. So I'll go ahead and hit play here. And if all goes well, the camera should now follow the ball. So yep, we're rolling around and the camera is following the ball just as expected. And this is a pretty good looking rollerball. This is pretty much identical to the classic rollerball tutorial. However, because it is dots, you know, I am gonna add in that last little crazy effect. And so I'm just gonna show you how to do that real quick. It's pretty simple to do. All right, so this actually all takes place within the GameManager script here. So I've added a couple more public variables. So I have a maximum score. So basically when we reach that maximum score, we're gonna trigger the insane mode. I have a public variable for how many cubes I want to spawn per frame. Of course, we have a public game object for the cube prefab, a public float for the cube speed, which we just set to 3 right now. This is the initial speed of when it's shooting up. A couple private variables. We have just a bool for the insane mode, as well as a private entity for the cube entity prefab. Only thing we need to do in the awake function here is just convert the cube prefab into the cube entity prefab. Down in the start function, just make sure we set this insane mode to false. And then in the update function, we're gonna check if we're not already in the insane mode and our current score is greater than or equal to the maximum score. We're gonna turn on insane mode, set that to true, and we'll just start this coroutine which says spawn lots of cubes. So basically this just checks while we're in the insane mode. We're gonna spawn however many cubes that we define in our cubes per frame. So we'll just do a yield return null, and this will just return every frame. And then the spawn new cube is gonna look much similar to the spawn new ball. Basically, we're just gonna create an entity, new cube entity, calling manager.instantiate the cube entity prefab. We'll set our vector3.direction to vector3.up. We'll set our vector3 speed equal to direction multiplied by the cube speed, which is that value that we set up there. And then we're gonna get a physics velocity component called velocity, and we'll set that equal to a new physics velocity. We'll set the initial linear speed equal to this vector3 speed. We're just gonna set angular equal to float3.0 because we don't need it to spin or anything by default. And of course, we're just gonna do a manager.add component, new cube entity, passing in this velocity component. And so that's all good. I'm just going to make another cube here, and I'm going to change just a couple things on here. So this will be the spawn cube, call it that. So it's going to be a little bit different. Instead of making it kinematic, we're going to make it a dynamic so that it actually is affected by gravity and everything like that. And we're going to turn off is trigger, so then this can, like, you know, collide with everything and do all kinds of crazy stuff like that. And I don't think we actually need this rotation speed data component, so we can just remove that. But otherwise, that's looking pretty good. And I'm just going to go ahead and save this spawn cube as its own prefab. We'll do a prefab variant, so we can delete that. Now on our game manager, we'll just put in the spawn cube variant onto our cube prefab, set a max score of 12 cubes per frame. We'll set that to 10, and I think that's looking pretty good. And this is it, baby, the final roll a ball. So here we go. We can collect the cubes. Of course, the camera is following the ball just as we want it to. And here we go. Are you guys ready for the insane mode? And of course you can see up in the editor here, insane mode, rollerball cubes, so much fun. And you can see in our entity debugger, like if we look at our stats, okay, my frames per second is dropping a little bit. We're at about 40 frames per second. We have about, 7,000 entities within our scene, all doing these gravity physics calculations. So that's pretty good. I suppose if we actually made a build of this game, it would run a little bit better while we're not, taking in all this debug data and everything like that. But anyways, that's how you roll a ball in Unity ECS. So once again, that is how you roll a ball in Unity using the new entity component system. I hope you found this video helpful. If you did, make sure you leave it a like and feel free to subscribe to the channel for lots more videos on the entity component system and the data-oriented technology stack. Of course, if you have any questions for me or suggestions for future videos, feel free to leave those down in the comments section below. But I hope you all have a fantastic rest of your day, and I'll see you in the next one.